Okay, the purpose of this video is to help you get a little more comfortable with a question involving a definite integral. So I've got limits of integration here, but they're not actually asking me to solve it. The answer to this entire expression would be a number, a numerical value. And notice my answer choices are not numerical values. So you're actually just trying to make an equivalent integral. So it is going to involve a u-substitution, which we've practiced. The only part that we haven't practiced is with the limits of integration. So they're telling me what to make u. That was very generous of them. So I'm going to go through and kind of start this the same way I always do. I guess I can just jump straight to my, since they told me this, my du dx. So du over dx is going to be cosine 2x, friendly reminder that we need to use chain rule. So times 2 is going to be in my entire derivative. And I'm going to go ahead and just put this in front there. So 2 times cosine 2x. If I solve for dx, that's going to be du over 2 cosine 2x is equal to dx. And then I'm going to go ahead and write my integral and make my substitutions. So let's go ahead and bring this down. And my sine to the 5th of 2x, that's going to become u to the 5th times cosine 2x. I have to just keep that there. And then this dx is going to be my other substitution, and that's going to become du over 2 times cosine 2x. Okay, so now I'm going to look at what I have, and again, that's just a rewrite of, I'll draw a line here because this is just my u-substitution there. So I'm rewriting my integral that I had. And what's going to end up happening here, as we like to happen, the cosine 2x's cancel out. I've got this 2 that's kind of left over, no big deal. Constants are not a problem. Just remember it's in the denominator when you bring it out front. And I end up with 1/2 integral of u to the 5th du when I clean it up. And if I had to integrate this, if the question was, like I said, do the whole process, no big deal, I would go ahead and do this. 1/2 times u to the 6th over 6th, or 1/6 u to the 6th, plus c. That would give me my, well, plus c if I'm not going to have limits of integration. If I do have limits of integration, I would keep it this way, 1/12 u to the 6th, and I would put my u back in, which is the sine of 2x, and it'd be sine to the 6th of 2x. And then I would evaluate it from pi over 6 to pi over 2. Okay, so I would plug those in. That is a skill you should be able to do, okay? But like I said, let's go back and actually answer this question. They want to know what matches. So I'm noticing that this is matching. I've got u to the 5th and all of these. So I guess I can eliminate the ones that don't have a 1/2 out front. That would be that one and that. So it's going to be B, C, or D. And the thing that's changing there is the limits of integration. Notice none of them have a pi over 2 and a pi over 6. And the reason is that these are x values here. And I had x right here. X was my variable inside my integral. But now my variable is u. So I need to actually use this equation that I have right here, and I need to solve for what would be the u value that would be associated with an x value of pi over 2. So if u is sine of 2x, then it's sine of 2 times pi over 2, and I'm just putting that in for my x value. And then I'm going to evaluate that. So that's sine of pi, and that's on my unit circle right here, which is 0. So this upper limit actually ends up being a 0. And then my lower limit of integration, well, I'm going to do the same thing with the pi over 6. So let's just do that right underneath it. That's going to be u equals sine of 2 times pi over 6. That becomes pi over 3. Sine of pi over 3 is this one, so it's the y value, which is radical 3 over 2. Good old trig. So I end up with radical 3 over 2 as my lower limit of integration and 0 for my upper limit of integration. So the correct answer choice here is D. Now, I could totally see why somebody would pick C. What might be bothering you here, if you actually stop and look at that integral that we just came up with, is that my limits of integration are kind of in backwards order from what we like, because we like for them to be the lower limit on the bottom. but we made the appropriate substitution. This had to be here because 0 was the one that I got when I plugged in pi over 2 into my u equation for x. So I can't just go and change things. I had to make the direct substitution. Now, what I could do if I wanted is I could decide to rewrite that integral, and I could switch it to 0 here and radical 3 over 2. But if I do that, then I have to make it a negative of what I would have had. So another possible answer, would be, I'd still have the 1/2 out front, would be that, and that would be equivalent. If I flip the limits of an integration, I have to change the sign of my answer, so it'd be a negative. That's not obviously one of the answers. Okay, but I did want to bring that up because sometimes I like to say, why did they put that answer choice on there? And that's why they did. Okay, hopefully that helps. Obviously, different ways to deal with it when you do go through and find the numerical value when you're just trying to match. You don't need to do any of this. So I did more work than I needed to here. You wouldn't need to do any of this part. Okay?